The first clue here is that we're being told this is happening at an exponential rate, and you should be able to recite what the elements of the exponential equation are by memory. A is the starting amount. B is the way it changes. And X is the number of times that happens. So the easiest thing we can go for here is to figure out how this changes, because an exponential equation is one that as X is going up by 1, we're multiplying Y. So these numbers are being multiplied. And if we want to find out what are they being multiplied by, then the easy way to do that is to go back in the opposite direction and divide. So if you go in your calculator and you do 5.0 times 10 to the 5th divided by 2.5 times 10 to the 5th, the answer will simply be 2. So this thing is being multiplied by 2. So right now we know that it's starting at some unknown amount. It's being multiplied by 2, and that's happening a certain number of times. So we're sort of up to there in the process. Now let's figure out what the starting amount is. So to get the starting amount, we're going to divide what we have by 2 yet again. Because this is the number of bacteria at the end of each day. In other words, at the end of day 1, it's already been growing. So the starting amount here would kind of be day 0. And so we can just divide by 2 to go in this direction. And what we're going to get is that on day 0, this is 1.25 times 10 to the 5th. So filling into our exponential equation again, we've got y is 1.25 times 10 to the 5th. And we know that it's being doubled X number of times for the number of days. So when it gets doubled once, we have 2.5 times 10 to the 5th. When it gets doubled twice, we have 5.0 times 10 to the 5th, and so on. So now we've kind of have the exponential equation. And if we knew how many days we were looking for, it would be easy because we could just plug that number right in here. But the question is asking us, when does this reach 5.12 times 10 to the 8th? And that's a y value right there. So the next thing to do is to plug that in as our y. So 5.12 times 10 to the 8th equals all this stuff that we have. Then we can divide both sides to get the 2 to the x by itself. And what you're going to get when you divide that out, when you do 5.12 times 10 to the 8th divided by 1.25 times 10 to the 5th, you're going to get 4,096. So right now we have 4,096 equals 2 to the x. Just going to just kind of reverse this and make it look like this, because that's more of a conventional appearance. And now there are two ways we can kind of proceed here. We can sort of try numbers and say, well, is 2 to the 11th equal to that? Is 2 to the 12th equal to that? And the answer is that it's going to be 12. But one important thing you're going to want to know is logarithms. Logs are invented to solve this situation when x is the power, because in algebra you can add to both sides, multiply, divide, subtract both sides, square root both sides, but you can't take both sides to an x power. So if I have a to the b equals c, the way to turn that into a logarithm is that the base stays the same and the other two things switch places. So this would be log base a of c equals b. The base stayed the same because this is the base in exponential form. This is the base in logarithmic form. and the C went left and the B went right. So the value of that is that it gives you something you can throw into the calculator. So for us, we would say log base 2 of 4,096 equals X. And that right there can go into your calculator. It can actually go into the calculator two different ways. If you know how to enter in a logarithm with a base, then you can do that on the TI-84. It's in the math button. But if you don't know how to do that, then you can know the change of base formula for logarithms. So for logs, if I have log base A of B, then that's the same as saying log B over log A. So once again, that's the log change of base formula. So we can call this log of 4,096 over log of 2, which is what X is equal to, and that's actually equal to 12. So like I said, you can find out that X is 12 by just trying numbers, or you can use the logarithm rules to find it. But either way here, the answer is 12. So that's T.